In previous class, I discussed about spherical mirrors. In this class, I am going to explain laws of reflection and spherical mirrors. The special properties of spherical mirrors are just an application of the laws of reflection. At every point, the spherical mirror reflects an incident ray in such a way that the angle of reflection equals the angle of incidence. Here we have to remember that the normal at the point of incidence is simply the radius of the sphere of which the given mirror is a part at that point. If a ray is incident in such a way that it passes through or appears to pass through the focus of a spherical mirror, it becomes parallel to its principal axis after reflection. A ray directed towards the center of curvature of a mirror retraces its path as it is incident normally on the mirror. We thus note that for a spherical mirror, first a ray parallel to principal axis passes through or appears to diverge from the focus of the mirror after reflection. You can see in these two pictures. Second, a ray directed towards the focus of a spherical mirror becomes parallel to its principal axis after reflection. Third, a ray directed towards the center of curvature of a spherical mirror retraces its path after reflection. We can use any two of these special rays to obtain the details of the image formed by spherical, concave and convex mirrors when the object is situated at different distances from the mirror. Do you know the minimum distance between an object and its real image formed by a concave mirror is 0 when an object is placed at C. In this activity, just we study the nature, size and position of image formed by different mirrors. Look at the image of your face in a plane mirror, then in a concave mirror and finally in a convex mirror. Does the image of your face seem to be in front or behind the mirror? It is inverted or erect. Does it look larger, smaller or the same size as your face? Move the mirror closer to and further away from your face. Does it make a difference? So just you record your observation here. You can then try to solve your observation, what you get by doing this activity. Compare the image of your face in a plane mirror and that formed in a convex mirror. In what way these images are different from each other? In what way are these images similar? In both cases, the image is virtual and erect. The convex mirror forms a diminished image, smaller in size, whereas the image formed by a plane mirror is the same size of the object. Image formed by a concave mirror. We use ray diagrams to find the details of the image formed by a concave mirror when the object initially supposed to be far away from the mirror is gradually brought nearer to the mirror. We show the relevant ray diagrams below. So just you can see in these pictures. First, when the object is far away beyond the center of curvature of the mirror, ray AL parallel to the principal axis gets reflected along LF. Ray ACN passing through the center of curvature gets reflected back along NCA. You can see in this picture, these two rays intersect at A dash. The image formed as A dash B dash. Image A dash B dash is therefore an inverted diminished image formed between F focus and C center of curvature of the mirror. It is a real image as the two reflected rays LF and NCA actually meet at the point A. Next, when the object is at the center of curvature, the two rays used here are AL and AFN. These reflected rays actually meet at A dash. In this case, a real inverted image is formed. It has the same size as the object. It is also formed at the center of curvature itself. You can see in this picture. Next, when the object is between the center of curvature and the focus of the mirror, the two rays used are as shown in the figure. The image formed in this case is a real inverted and enlarged one. It is formed beyond the center of the curvature. Next, when the object is at the focus of the mirror, the two reflected rays here are parallel to each other. Therefore, they do not meet. We, however, say that they meet at infinity or at a point very far away. Thus, in this case, we get a real inverted and enlarged image formed at infinity. Next, when the object is between the focus and the pole of the mirror, the two reflected rays are seen to move away or diverge from each other. They, however, appear to meet at a point A dash behind the mirror. Thus, in this case, we get a virtual, erect and enlarged image that appears to be formed behind the mirror. Next, image formed by a convex mirror. The same method can be used to draw ray diagrams for a convex mirror. Here, however, no matter where the object is, we get an image that is always virtual, erect and diminished and is formed between the focus and the pole of the mirror. You can see in this picture. So, we summarize these results for the two mirrors in the form of a table. You can see so in this class you just studied about these images formed by a concave mirror and the size of the image formed when they are placed in the object is placed in different situations. So just try to draw these diagrams in your notebook, and you are also likely to learn these words of mirrors. We often put concave and convex mirrors to a number of practical uses. Concave mirrors are used by ENT doctors as head mirrors. They have this mirror strapped on their head. Light from a lamp is made to fall on the mirror. that after reflection from it gets focused onto the throat or ear of the patient. The doctor is then able to examine that part clearly. Next, dentists also use concave mirrors to get a magnified image of the teeth. Concave mirrors also serve as reflectors of light in torches. Convex mirrors serve as good rear view mirrors in motor vehicles. They help the drivers to see the traffic behind them over a wide range of view. You might have seen eye specialists using a special instrument called the ophthalmoscope. It is fitted with a concave mirror having a small hole near its center. The concave mirror helps the doctor to direct a beam of light into the patient's eye and see his/her retina clearly through the hole in the mirror. We all know that we need telescopes for viewing distant heavenly objects. Telescopes are made by using either convex lenses or suitably shaped curved mirrors. Of the two telescopes made by using mirrors are better in several respects. Curved mirrors are therefore used in designing large reflector type telescopes. You can see in this figure also. People need plain mirrors while dressing up, combing the hairs, shaving the beard, and so on. As we already know that plain mirrors are used in the kaleidoscope. Similarly, plain mirrors are also used in designing scientific meters and the periscope. The periscope is a simple device that enables us to see overhead objects that are not directly in the range of our sight. So, you can see here the practical uses of mirrors and lenses in our daily life. So, you are advised to go through the chapter and try to draw these ray diagrams in your notebook. Thank you.